Hello everyone, this is Dr. Sujit Panda. Today I am going to talk about the introduction to Geographic Information System. This is the first lecture on GIS. GIS, Geographic Information System, is a consist of three words: Geographic Information and System. Here the G means Geographic and IS, that means Information System. Information system with geographically referenced data. That means the data must have the geographic location. Here geographic location means the related to geographic coordinate system, not geometric coordinate system. Another word is information. Here the information means related to data. That means the attributes which correspond to that location, and this attribute should be manipulate, edit, summarize, query, analyze and visualized. Another word is system means here the system is related to computer, because the all the uh, um, data correspond to geographic location is processed in computer system. That's why we told the geographic information system. The information system produced to provide information for decision making. These are the some terminology of GIS. Geographic information system, when it used as a technology or tool by means of cartographer. Geographic information science, when we use as a science or theory. When we talk about the concept and theory, that time we says this is geographic information science. Another word is geoinformatics. In European country, they are the very used to in this terminology, geoinformatics. Another word is geomatics. Geomatics means geo and measurement. Canadian and USS are use this type of word for GIS, and this geomatics also used as a surveying field. When you use the surveying system in GIS, that time we also talk about the geoinformatics. Another word is geospatial system. This is used for different technique, also added various techniques into it. Spatial information system also similar to geospatial system. Geospatial information engineering, when we uh, use the GIS in civil engineering field like dam construction, etc., then we use geospatial information engineering. Geospatial information study, when we talk about social context, when we use the GIS in to represent the any social context, then we also called uh, geospatial information study. Another word is land information system. Next one is geographic information service. Website and services for cultural use, travel, etc. Um, like services Google for route planning. That time we also use the geographic information services. Evolution of acronomy of GIS. In 1980s, the Geographic Information System is very popular. In 1980s, it is known as a Geographic Information System. In 1990s, we also use the Geographic Information Science, and uh, another one is Geographic Information Service. This Geographic Information Service is introduced around 2000 or after 2000. Now the history of GIS. Roger Tomlinson, who is the English geographer, primarily originator of modern computerized geographic information system. That's why we know him as a father of GIS. In 1963 or 1964, he was as the creation and manage the Canadian Geographic Information System. This is the first national GIS system. After that, in 1967, the Land Use and Natural Resource Inventory System was introduced in New York. After 2 years of this, in 1969, Minnesota Land Management System is introduced. After that, in 1981, the Info introduced as a first major commercial GIS venue. The Internet GIS and mobile GIS are found in market after 2000. In that time, the open access satellite images like a Google Earth, Landsat image, etc. are also available in market or freely available, start as a freely available. The students, researchers and pupils are getting this data, Google Earth and Landsat image in free basis. Nowadays, the GIS and spatial analysis are being used by everyone. Location-based search facilities available in Google. Use of an app on our mobile phone to get the shortest route from A to B. We can track our parcel delivery or we can book the car, taxi through our mobile phone. Now, what is GIS? A GIS or Geographic Information System is a computer-based system or computer-based tool for data capture, data storage, data manipulate and manage and analysis. And after that, mapping and display the things that exist and even that happened on Earth in future. Therefore, the major functions of GIS are capture the data, data storage, data manipulation, data retrieve, data analysis and model, display and output. Data can be captured from variety of source. It may be from primary survey-based data, it may be from scan document data, it may be from satellite data, and so on. After data capture or data collection, it is very essential to store that data efficiently. Why efficiently? If the data is stored efficiently, data can easily be retrieved and data can be manipulated or edited if required. So efficiently data store is very important, and as this is a computer based system, the GIS can accept the large volume of data, and these data may be managed or stored as a database management system or any data storage structure. GIS also offers the data manipulation and data retrieve or query system. If data is stored efficiently or organized the data very well, we can edit or manipulate the data, and if required we can retrieve or apply query, retrieve the data. For planning and future prediction or change analysis, we can also use the different type of model and apply on those GIS data. After that, we can analyze and visualize the data. We can display the result or output as map, chart, pie diagram, tabular form, or as a report form. These all are depends on user specific. Now the purpose of GIS or why GIS? Why we use GIS. 70% of information includes some geographic fact in decision-making process. GIS not only keep or store the data, it also monitor the data resources. It also provide the analysis and model the data to predict and planning. And it also simultaneously potential the impact of management alternatives. GIS also can describe the spatial relationship. It can describe the nearer feature and how far or how close to this from targeted location or targeted features. Old map and records are poorly maintained as it was in hard copy format. GIS also a digitalized system and data also stored in digital platform. So we can generate the map not only one or two times. We can generate the map for many times. We can make map many more times, and, and this digital map data is more secure and better organized. The data redundancy and other problems of multiple map set are eliminated. Maps update or revision are very easier and faster. In older system, there is a hard copy map. If found some error, it is very difficult to revise and erase. GIS also help to search, analyze and present the map data. What is nearby? What is in this area? What else can you tell me about this? What area have both of these characters? We can easily convert the unit of all data in a 1 or 2 second or within a little bit time through GIS. GIS also a time and money saving or money consuming system. It also help us to better decision make. Now, data versus information. Data is of little use unless it is transformed into information. Information is an answer to question based on raw data. That means data is meaningless or valueless. Raw data is valueless. When we add any context to it, it becomes information. And GIS is a platform by which we can transform the data into information. So this is data and add some context and process it to information. Data is the raw fact or raw measurement of world. It can be any text, number, character, image, word, means little anything to a man. But when data is processed, organized and presented with a context, it become a useful. Then we called this is information. Data alone can never be a significant. For example, here this is a 2964. What is this? We don't know. This is a simple numerical digit 2964. When we add some context like this is a rainfall in millimeter, then this will be a meaningful information. Then this is meaningful. So the information is always important by itself. On the other hand, data is independent. So data is not dependent on information, but information is dependent. Information is dependent on data. If I say millimeter, what is this? There is nothing. When we add some numerical data like 29, 30, then we can say this is 30 millimeter, 30 centimeter. When data is lost, it cannot be reproduced. But when information is lost, it can be reproduced from data, because we have a data. Just only add context to that data and it become information. So the data is meaningless or valueless, but information is meaningful and valuable. Therefore, after process or analyze the data, it become information. This is some example. Here some example, like this is the AERTH. What is this? This is a meaningless or valueless, and this is like a just only text or letter. But when we add some context, it become EARTH. That means earth. When is represented in graphical, this is a earth. Okay. So the data is equal to fact, but information is equal to fact and meaning. Here is the another step when data, when we add context and process, then it becomes information. For example, 52, 78, 59, 83, 66, 70. This is meaningless. This is a simple number digit. When we add some context into this data, like a test score achieved by student, then it become an information, and meaningful information. Like a this is the average test score of 68%. Another information is students test score is assessed. Okay. Now data versus information versus knowledge. Data is often raw representation of any number or character. Information is anything that put context to data. And knowledge is express that how things are work around us and how the large world is interconnected with them. The data is simply numeric or any character or any little things, and information is the meaningful context when it add to data. When we can get the information or knowledge about those things, what and how these are work around us, then it's become a knowledge. For example, here the data is 91. This is the no meaning, just number. When we add the information kilometer per hour, that is the information, and this is the meaningful, then 91 kilometer per hour. And after that, when it apply in real world, we can get knowledge about 91 kilometer per hour. That means this is the speed. So we also says that the above 60 kilometer per hour is accident prone. So this is the knowledge about the real world things which work around us. So we can says that in GIS, when data become information and information goes through the GIS or GIS model, it become knowledge. Now, why GIS is unique? Because the GIS handles spatial location information in space. That means in GIS, every data should be the locational information. GIS also make the connectivity between activities based on spatial proximity. Here proximity means the distance, the spatial distance. So we can correlate anything, any object, by the spatial distance, how far or how close the object, etc. We also can answer the real world problem like a where, what is there, what is the best route, what relation exists between, what has changed since, what if. These are the some basic problems, and when we go through the GIS, what GIS can do over these questions. That means where means identification. That means we answer this is the location. We want locational information. What is there? That means we want information on that location that should be in form of attribute. If we get attribute, we can apply spatial query to get information our interest. What is the best route? That means the optimum route or path. That means we can get the answer, the distance between 2 points. What is the relationship between some objects? That means that we can use the pattern analysis. For pattern analysis, required minimum 3 image or 3 type of data, 3 level of 3 temporal data. That will be different time. And now the what has changed since, that means the trend analysis. For temporal analysis or trend analysis, this is required minimum 2 image or 2 temporal data. What if? That means the we can use the model to predict the future scenario of our interest. So what is the character of spatial data? Spatial data can answer this question: where, what, how, and when. This is the real world example how GIS work. First of all, this is globe. For example, I want to know the information about this point, which is marked in red over this globe. When it's zoomed, this location is 22 degree 8 minute 14.22 second north and 29 minute 24.19 second east. This is the locational information. Based on this, we can give the information what is there in real world. When we go to the field or ground truth point to get the information, real world information, we can answer the question, what is it? Here we can collect the information like a object. Here object is mines or mining area. What is the mineral is iron ore. What is the grade is hematite. Now we can put this information as a attribute information against this location, this coordinate. In this way we can describe any object of real world into 2 ways. One is where, that means we get locational information. Another thing is what is it, we can get the other information or other data against this location. In this way we can create a database, GIS database for iron ore mines where is these are located, and after that not only iron ore mines, we can store the information for any mineral or any mining. And when we store all this data in GIS, after that we can search the iron ore mines not only single mines, we can also select all the iron ore mines location by using query tool. We will select the single input as a iron ore mines and search for query, and after that and we can get the all mining information, all iron ore mines information in a 1 or 2 seconds. And these are the stages of GIS. First, the problem define. Here, find the problem or define the aim and objects. What is your object of the project? First of all, problem define. We can find the problem, or you can define the aim and objective of your projects or of your requirement. Second stage is software and hardware. If we select our aim or objective, after that it is necessary the requirement fulfill the requirement of software and hardware. Softwares are required to process the data, geospatial data, and hardware is also required to install those software. There are many free software, QES, OpenJam, etc., and also available commercial software, IGS, ADAS Imagine, etc. Next stage is database and manipulation. To fulfill your aim and object, there is basic needs is the database or data. Data should be clean and reliable data with spatial reference for better result. Now the why reliable data? If data is meaningful and clean and authentic, we can calculate the distance, and we can analyze the things which is adjacent to that location. We can change the projection and scale if required, and also we can uh, integrate or join the another data to that location if required. And those data may be from different source. And this is also very important things, that all the data which are collected from different source, that must be converted or transferred into in GIS environment or GIS platform. Now the next stage is analysis. After generating the reliable database, we can analyze and modeling if required to achieve our aim or to achieve our objectives. This analysis may be in qualitative or quantitative or exploratory spatial data analysis. And after that, the interpretation and findings. Interpretation and present the result. After analysis, we can present the result by map or through table or graph or as a report. After that, after visualizing the result or report, the user can use those reports or information as per their requirement. In these stages, the data manipulation, analysis, and interpretation also and findings. These are the main uh, three stages which is under a GIS toolkit. These three are the main toolkit of GIS. Now the type of GIS. The type of GIS ranges from high power analytical software to visual web application, and each of these are used for different purpose, but the all are the common characteristics, but their functions are different. Here the main three classes of GIS are desktop GIS, geo browser, and C web-based GIS. Desktop GIS. A desktop GIS is a mapping software that needs to install and run on a personal computer. and GIS data also need in the same PC to develop GIS or implement the GIS. Those data may be in external hard disks or pen drive, but it must be connected to that PC. It is a single-use GIS, but a generic system because it can be used for variety of project or research activities. These are some example of desktop GIS, ArcGIS desktop, QGIS, etc. ArcGIS is the commercial software, but QGIS is used for a vast range of activity covering both commercial and educational use. As it is for educational use, this is also a open source software. Geo browser. Second is geo browser. A geo browser can be better explained with reference to an internet browser. In short, a geo browser can be understood as an internet explorer for geographic information system. Like the internet, it allows the combination of different type of geographical data from different sources. In geographic web, everything is spatially referenced. For example, Google Earth. This is the most popular geo browser. This type of geo browser or GIS work through the internet browser, and the tools are limited, not the vast like a desktop GIS. Now third is web-based GIS. Web-based GIS or WebGIS are online GIS application. In most cases are used as a excellent data visualization tool. The data or software are stored in a server system and user are used simultaneously used through online. It means the functionality of this GIS is limited in respect to GIS desktop or desktop GIS. It is user friendly and particularly used as they are not require data download. In this case, the data download is not required. We can analyze or get information directly through uh, this platform. These are this web-based GIS is designed for specific purpose, specific project. For example, GIS-based water resource system. There we can only analyze the water related information, what the watershed or any drainage information. Now the professional GIS is readily available for targeted user. For example, GIS for forestry, GIS for urban, GIS for water resource management, etc. Another one is the enterprises GIS. Here the number of user or multiple user use this simultaneously. In this case, the data and software are stored in a server system and all users are use this software and data simultaneously. Another one is the mobile GIS. This GIS system is work on mobile or function in mobile. For example, we can track the location information or road to reach some location by using the mobile map, mobile live location map. These are also the part of mobile GIS. Another one is embedded GIS. This is developed GIS for particular hardware or device with inbuilt map, like a car route map. In this case, a hard key also developed, and that hard key connect to that hardware for which this is developed. Now the 3D GIS and multimedia GIS. In 3D GIS, you can get the information of three dimension like a location, XY location, and also we can get the information of the altitude or height. When we use the GPS or mobile GPS, by which we can get the information like a location, like latitude, longitude, and elevation information. These all are in under 3D GIS, three-dimensional geographic information system. Another thing is multimedia GIS. Here we can attach any song, video with the map or the database. We can link the song, videos, or maps into the particular location or particular object or particular database. And these are the some integrating technology like remote sensing, cartography, GPS, GNS, computer, RDMS, information and communication technology, survey and field data collection. In remote sensing, we use the satellite based data and information into GIS. In cartography, we can create the cartographic map and use the variety of symbology, scale, etc. to get the information by map. In GPS also use to collect primary location information for any object, and we can integrate that data into GIS. Computer system also required to install the GIS softwares. The personal computer is also a integrating technology. And that thing is RDMS, Relational Database Management System. This is a database management system which is used to query or search the data into the GIS. We can also integrate the information and communication technology into GIS, survey and field data collect and correlate or present through the GIS. Now these are the basic uses of GIS. We can natural resource management, topography, geology, hydrology, demography, disaster management system. These are the basic field where we can use the GIS. GIS also used to generate the contour map, slope direction, etc. for topographic. And GIS also used for infrastructure development like a transportation system. The location of road, railway network, airport location, etc. are mapped through GIS, and railway route mapping system is the best example of the application of GIS for transportation system. And another good example, real life example is Ola taxi. When we booked Ola or Uber vehicle, we can see the optimum route or path of the of our journey route through mobile. Nowadays, GIS also used for utility services like a pipeline, like a oil, water alignment route. Whether this alignment or route as passing through a forest or any government or private land. What are the distance passing through the forest or government land? We can get information easily through the GIS mapping. GIS also used to mapping for health center or hospital location. These locations are also help us to get the nearest hospital or and ambulance facility at the time of emergency or emergency time, which is the best and nearest hospital location. We can get that information through GIS. We can easily identify the malaria prone area by map and what is the spreading direction. The best example is the COVID-19. In that time, government easily present the number of COVID cases or COVID density, state-wise and as well as district-wise to alert people. Sometimes the GIS also used for investigation service, the crime source, crime pattern analysis, what are the type of crime, etc. For example, what are the robbery prone area and why? Is it economically backward area or dense populated area, etc. What are the best and shortest route to escape the thief after perform the robbery? Thank you.